is this. Before I get started, I want to kind of kick around an idea and throw it out to you guys and see what you think. Part of the reason this talk was built was to kind of fill the need.
We have a long time tradition. If you talk about assembly at SetKC, you have to do a shot.
Was that Jaeger?
Yes.
All right. So real quick, the assembly level 0 badge up there that you see, this is really the idea, and I'm looking for feedback, not necessarily right now, but it's really to fill a need where I see a lot of talks over the course of SetKC. We've been here, how long? 4 years? 5 years? And guys, the talks that you guys see at SetKC is a snippet of what you're going to see at a bigger level conference. DerbyCon, ShmooCon, DEFCON. Guys, these are the talks that you want to be at. This is the material that's being presented here is amazing. And I think a big round of applause to all the presenters, especially Thomas. Thomas, good job tonight. All right, guys, so here's the idea. I want to really start thinking about if you're a presenter or if you're an attendee, I want to start tagging talks with maybe a level of how that talk, how you feel as a presenter that talk will resonate with the audience. Or as an audience member, you know, what to expect. I go to talks.setkc.org and I see, okay, I've got a level 3 talk, which is an expert talk. Am I an expert in that topic? No, that's definitely a talk I want to be at. Right? You do not want to live in level 0 and level 1. There are people who need to be in level 0 and level 1, and that's awesome. My talk right now lives in level 0. Okay, so I really kind of feel like if we can span that spectrum of talks, we are hitting the audience and we're doing what we're here to do. Why are we here?
Educate.
Educate and learn. That's exactly right. So guys, my talk right now kind of lives at level 0, maybe level 1. Okay, assembly language as presented. When you hear assembly language, what do you think? You think level 0? God, I don't. I hate assembly. It's on fleek. Does somebody say on fleek? If you said on fleek, see me after. I got something to tell you, pal. All right, so here's what I think when I see assembly. 12 is kind of high. Did I just get horned? Well, I don't even know what that is.
It's an audible shriek. How old is that shit?
Aww. This is very reminiscent of Trixie already. All right, guys, so let's just jump right into it. We're at level 0. Keep that in mind, okay? We're not gonna write shell code tonight. We're not gonna write assembly code on screen. No, none of that. We're gonna, maybe for Andy later, like in a secret room back there. All right, so what's assembly? What is assembly? All right, assembly is a programming language that's the lowest level of abstraction to the CPU without being machine code. So before I'm issuing commands directly to the CPU, I'm writing in assembly. Okay, that sounds super boring to me. But we need to understand it. Assembly is dependent on the platform, so we're going to focus on X86. So if I start writing assembly in just whatever, pick the processor, that's what we need to focus on. So we're going to focus on X86 and 64-bit, and we'll kind of get into that. And really we'll kind of cover why we're going to talk, how we're going to learn assembly. Because right now, 15 minutes is not near enough to learn assembly. Actually, maybe it is for some of you. So why do we want to learn assembly? Why do we want to learn X86-64 assembly? Anybody? If anybody can answer, I got a coin for you.
Because you said so.
Reverse engineering. Okay, come get. I got a coin right here. Come get it. Shell code. All right. Maybe we want to learn about. Maybe we want to reverse goodware and malware. Maybe our sandbox environment just had a 0-day drop and we don't trust it. I don't know what that is. And really, because learning assembly, or learning anything, is, we're not getting weaker learning something. We're getting stronger learning something, and strength is never a weakness. It's kind of the, ugh. So one of the things that I want to do here, besides why we want to learn it, and X86 is everywhere. It's not on our phones yet, but it will be. But one of the things I want to do, guys, is provide a learning platform and support structure to learn assembly. So no, we're not going to learn it right here in this talk. No, we're not learning everything we need to know. But what I want to do is be there and create a path for you to learn that. And then as a collective, as a SecKC collective, we can learn these things. Not only that, but guys, when we have, let's look at Kevin and Patrick's challenge, all right? If we know assembly, we know we are stronger at solving challenges. Not only that, but when we go to DEF CON and SecKC destroys that shit, then what? Hell yeah, right? So
when I get a chance to kill Englishmen.
God, you guys are so mean. All right, fine, I'll move it along. All right, so here is how we're going to learn assembly. All right? God, that's hideous. Who can't see that? Everybody? All right, hold up. Are you talking smack, Trent? Yep. All right. So we don't, this slide, so here's what I'm going to do. This slide is going to be in the Slack channel, which is already, there's already a Slack channel for assembly created. So I'll just walk you through it real quick. In the middle of this is the SecKC X86-64 Assembly 101 talk, which you're in right now. And what we need to learn over here on the left is architecture, registers, Indianness, the stack, instructions, tools, yada, 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 yada. Okay? We're not going to cover, again, this is a basic level talk. We're not going to cover that right now in depth because it goes against the spirit of the talk.
Pop, pop, red.
Pop, pop, red. That's right. Donnie Hubner gave a talk, what was it, 2 years ago?
Yeah, forever.
All right, what was your talk about? Buffer overflow? Okay, buffer overflow. Who went to that talk? All right, a couple people? That shows how big we are. We've grown. How many people understood every assembly instruction in that talk? Okay, Thomas did. Of course, Thomas did. So, I'm not going to spend a lot of time on this. We're going to learn everything on the left, and to accomplish that, we're going to do everything on the right. And the things on the right, I've set up a SecKC reverse engineering lab. Okay, I have a Slack channel for this very talk. Micro corruption, which is a reverse engineering game. And a Bitbucket repository I've set up, et cetera, et cetera, et cetera. And I promise you, when we're done with all of that, however long that takes outside of this talk, you guys are going to be like Harold. You see assembly and you're going to be like, yes. All right, so we'll get as an intro to assembly talk if we don't learn a couple of instructions. Okay? Finally, get on with it, right? Classic Cory talking about his power glove for an hour and a half, and then I get it. Okay, I get it. You suck, pal. You get up here. I'm just kidding. All right, so instructions. What are instructions? To the CPU. What are instructions? Instruction set in assembly, in that context, is a set of math instructions that the processor can execute. Okay, that's as far as we're going to touch it right now. All right, so the two things that we're going to learn tonight are push and pop. And so I got to tell you, I was telling Trent, I wanted to bring 500 push pops tonight. You know that candy? Like push pop, nothing, two laughs. All right, so here we go. So to learn push and pop, we have to kind of assume the stack. Now, what's the stack? Anybody? I'll give you a coin if you can explain it.
Data structure.
Data structure?
Last in, first out.
Last in, first out, okay.
Put things on the stack and you have to remove them first before getting it down from the stack.
You're not getting a coin.
I know.
Yeah, you already have a coin, pal.
Push something on,
Push something on,
pop it off.
pop it off, okay? So the stack, as we're going to envision it right now, all right? We're going to envision the stack a couple different ways. First way this is a blank Word document. That hole you see right there, blank Word doc, okay? And the stack is a conceptual area of memory which is designated to the OS for the program to run, okay? That's the this is a Word document version of that, all right? So we have a Word document, and here's what I want you to envision. When we push something onto the stack, we're typing a word in our Word document. When I press Control-Z in that Word document, I want to undo what I just did. We're popping that off the stack, okay? So that's just keep that in mind. All right, so we are going to type our word, which is actually a SetKC logo, push. We're going to push that next word on the stack. We're going to push the next one on, okay? So as you can see, black, red, green, last in, first out. So the last thing we pushed onto the stack is the first thing that's coming off. All right, let's go through this real quick. So in that order, we're gonna start popping stuff off the stack, just like that. Undo, redo, think of it in terms like that. Okay? Now, that's the stack. Again, guys, this is, keep in mind, basic level 1. We're not digging into it. This is a 15-minute talk. If it was worse, or if it was longer, you guys would be like, oh my God, get your power glove. All right, so real quick, to understand assembly, we have to cover certain things. We have to cover syntax, okay? So maybe let me pop this stuff off. All right, so this is an eye chart. I get it. All right, all we want to cover on this chart, all we want to cover on the slide is when you think of Intel syntax, I want you guys to think of algebra or C if you're so inclined. So when we think of the order of operations, right? So real quick to cover that, the two gray boxes are saying the exact same thing in different syntax. Exact same thing. All right? So what we're going to do is we're going to focus on Intel syntax, mainly because, let's see what I wrote here. Okay. Well, good enough. We'll just move on. Who's bored?
Not me. Not even a little bit.
All right, good. Good. So guys, to cover the things that we want to cover, I'm really jumping around. To do an assembly level basic talk, we're glossing over things that are huge concepts, okay? But that, again, is why if you go back to that eye chart that Trent talked about, like that is why I want to build the support structure. So if somebody in this audience is a level 5 or a level elite or a level whatever, and they're like, this talk is super beneath me, pal, you're not, this is weak. Guys, I encourage you to jump in that Slack room and start helping us, okay? Let's learn it together. All right, so we're going to learn a couple registers. All right, we're only going to learn registers in the context of doing a demo. All right? Yes, sir. Question.
Why are there R's instead of B's on that slide?
Why are there R's instead of B's on that slide? Spell check.
RSP versus ESP versus
RSP versus ESP, right. So I think that's a little too advanced. Okay. Just R's equal E's. That's what we need to know.
Awesome.
Okay. Good point. All right, so we're not gonna spend a lot of time on this. RBP, stack base pointer, RSP, stack pointer, RDI, destination pointer for string operations, RAX, stores function and returns values. Okay, that's all. Like just accept it. All right, so here's how we're going to demonstrate this. Again, 15 minutes. I'm not going to spend a lot of time. Who recognizes the syntax of that code? C. That's right. So here's another way to visualize the C code. Okay, that's the same thing. That's the exact same thing. Who can interpret that as easy as they can interpret this? Who gets a piece of malware that has the C code packaged with it? Anybody?
Nope.
Okay. Okay. All right, so this is back to the syntax slide. As you guys can see, one of the things that's important to note, let me see if my green laser works. You see these percents? So this is AT&T syntax. So if we think about the order of operations here, this is just to demonstrate syntax. This is Intel syntax. Okay, this is exact same thing. Exact same thing. All right. So here's what we're going to do. We're going to do this. I know, it's hideous. All right, who's taking notes? Probably nobody. That's fine. Okay, so these slides are going to be in the Slack room. Okay, and I encourage everyone who's interested, go through this exercise. The instructions are right here. All right, and we'll go through it together. If you get stuck, et cetera, we'll go through it together. So, who knows what GCC is? Who knows what this top line means right here? Oops. Compile C. Somebody other than Brian. I'm just kidding, Brian. I'm just totally kidding. Who knows what GCC is?
The C compiler. GNU C compiler.
What's that?
It's the standard C compiler on Linux.
Okay, standard C compiler on Linux. That's right. What does the switch GGDB mean? Debug. That's right. That's right. Why do we want to include that switch?
Because it shows you the code.
You want to debug it.
Because we want to debug it. That's right. All right. So the O switch tells us our output file of the compiled thing. All right. And then our input file is that setkc.c. And as you guys can see, dang it. I've used a computer before, I swear to God. All right, so here's the contents of setkc.c, right down there. Very simple. You guys can copy this, paste it, and then run through these exact commands. Okay, and what you're gonna learn, and what we're gonna do is we're gonna start stepping through, and we're gonna start turning it into, okay, everything we learned about the registers and the instructions, we're gonna look at those things, okay? So, do you guys want to see the demo, or you want me to skip that, or what do you think? Demo? Okay. Okay. Just make sure. All right, hold on. Let me get this set up. Great to the demo.
I might have to zoom that in a bit. Yeah, there you go. A little bit more. That'll work.
Work? All right. All right.
That was Joel messing with me.
Right. I get it. Let's play him off. Like, I get the whole thing. Okay. All right. Everybody can read this?
Yeah.
All right, good. So, what we're going to do, I wish I had that. We're going to mute our mic. All right, hold on. I'm going to be like a professional here. Oh, sorry.
When does that start?
That's hilarious. Okay, typing. Oh my God, this is impossible. I'm moving. Okay, here we go. So what I said, the first thing we're going to do is,
GCC.
actually, peep this. Uh-oh, what's that? Ano. Uh-oh.
What, no Pico?
That's right. That's right, Pico. I refuse to use VI.
Yes. Oh! Yes.
Mic drop, I swear to God, I was
You're
going to mic drop.
banned.
All right, guys, there's our code. All right, let's go ahead and compile that stuff.
Watch it throw a compiler error.
What'd you say, Thomas?
I said watch it throw a compiler error.
I'll throw you a compiler error. I'll sudo your root, pal.
I'll sudo your group.
All right, so What we've done is we've issued our compiling command. We've said we wanted debug commands on, or debug symbols on, right? And we tell it this is our output, setKC, and we need to give it our input file, setKC.c. Uh-oh, Thomas. Guess what? Look at that. What happened?
Warning.
Right. All right, so guys, here's what we're going to do. If you didn't memorize the previous slide, we're at challenge time. What we want to do is we want to find the base memory address of the string. I'm too sexy for a GUI. Okay? So that's what we're after.
Object dump.
Object dump. I love it. Yes, that's correct. So what we're going to do is we're going to type object dump. If I can focus. D setKC. Oops. And we're going to ask it. We're going to tell it. All right. What is this? Somebody tell me what we're looking at.
Assembly.
Disassembly of section dot
Matrix.
Disassembly of section of what?
dot init.
Okay.
Where's the GUI?
There is no GUI. All right.
Is there a spoon? Need a mouse.
All right. I'm going to tell you guys what we're after. If we went back to our C code, we saw how do we start this program? What do we have to do?
The main function.
The main function is what we're after.
So can you push it out way out?
We can push it out, way out. Push it out.
Start right there.
All right, so I'm going to just quickly burn through this. We're looking for the main function. Why are we looking for the main function?
Is this the matrix?
That's how C starts.
That's how C starts, that's right. So guys, here's the representation. Does anybody see a problem with what I said earlier versus what I see now?
There's a bunch of extra instructions.
I see some E's. All the R's are lowercase.
All the R's are lowercase, that's pretty good.
I see some E's.
All right, I want to point something out. What syntax are we looking at?
Intel. Or AT&T.
AT&T syntax is exactly what we're looking at. I told you we were going to focus on Intel syntax. That's right. I don't like that. I don't know how to read it. Well, I mean, I don't know how to read in general, but. So guys, we're going to quit this by pressing Q. All right, and here's what we're going to do. We're going to use GDB to disassemble this thing. Who can tell me what GDB does?
The debugger.
It's a debugger. That's right. What do we use it for? To understand what the program's doing. All right? All right, so we're going to use GDB. And again, everything I'm doing right now is in the slides. And I know this is intro talk, but we are going to cover exactly why all this works. And so when you're in front of a piece of malware, it's not this easy. And we're going to show you how to step through every single thing, understand the instructions, yada, yada, yada. Next thing you know, we're reverse engineers and we making a 2 million code known. Right? I mean, that's my plan.
Yeah.
All right. So let's quickly burn through this. I don't know what my time's like.
Time is fine.
Okay, cool. So GDB, we're in the debugging platform. We're in the debugging. What do I want to say?
Debugger.
We're in the debugger to look at our program. Okay. So in the slides, let me just point out real quick. I have every command you need to type. And when you see parentheses GDB, exactly like it's right here, that just means issue the command right after you see this once you're in GDB, okay? So the first thing we want to do,
Set a breakpoint.
set a breakpoint. That is an amazing suggestion, by the way. Okay, that is not what we want to do. What we want to do is we want to set disassembly.
Oh, right. Intel.
Oh my God, am I even typing this right? All right.
Flavor.
Flavor to what? What did I say? we're gonna use? Intel. That's right. Shut up.
Cory, you're doing an amazing job. But
All right. So we.
serious.
What?
You're doing an amazing job.
Oh, thanks.
Typing in real time. That's
Thanks. Okay, so guys, we have set our debugger in exactly how we want to view it. Okay, we don't want to see Intel, or I'm sorry, we do want to see Intel. We don't want to see AT&T. All right, because we're on the Linux platform. If we're debugging this in Visual Studio Express 2000X, we're going to be presented with a different presentation of this exact thing. Okay, and yes, what we're we are going to do everything in command line. So here's, we're going to work in command line, and we're going to eventually work up to a GUI, because GUIs are amazing.
GUIs suck.
GUIs suck. That's
What's that stand for?
Trent asked what GUI stands for. Can anybody help me out?
Graphical user interface.
Wrong, girls use it. Uh-oh! I just got banned from second. I swear to God, I just got banned from second. I'm sorry, it's just a joke. It's just a joke. Okay. So what do we want to do first? All right, set a breakpoint is awesome.
Disassemble main.
Okay. Yes, Alex said disassemble main. Yes, but how do we know we want to disassemble main? All right.
Because we looked at it.
We did look at it first, but let's just pretend we were stupid and we forgot.
We should look at it again.
We should look at it again. How about this? Uh-oh.
Oh, and it'll show you.
We tell it list. All right, what do we know now? Oh, there's my main. Okay, I probably want to set a breakpoint at main, right? Because keep in mind, guys, the challenge is we want to know the memory address of where that function, I'm too sexy for a GUI, is being printed. Okay? Set a breakpoint?
What's a breakpoint?
What is a breakpoint? A breakpoint is we're telling the disassembler, when you get here, stop. Right?
Break main or two.
Main or two?
Main or two.
Main or two? Yes. So that's a good point. So to set a breakpoint, you can do a couple things. You can type break, main, all right? Sweet. I love it. Or, because I'm super lazy and fat, I type break 2. Okay? B equals break. I know it's 2, and I know B is short for break. All right, sweet. Okay, now what do I want to do?
It starts with an R.
It does start with an R. I want to run the program, and I want it to stop at my breakpoint. Okay? Uh-oh. Sweet. It stopped at our breakpoint. Okay? It did not return. So if we went back to the C, you're going to see when it completes, it's going to return lead. Okay? Now, to Alex's point, what we want to do is we want to disassemble. We want to disassemble main. Okay? Because the objective of what we're doing is we want to know the memory address in the what?
In the memory?
In the stack. In the stack of where this thing is. All right? Let's just pretend we're dealing with shellcode. We want to know where the thing is. Right? We want to disassemble main. What's that give us? Oh, God. Seriously. I hate even looking at this. All right. So, if we went back a couple slides, I've called out these registers. RBP is what?
Base pointer.
Base pointer. All right. So, because we're in Intel syntax, and everything on the right is being copied into the left. Okay. All right, so we see, let's move down. We haven't even looked at move. Okay, MOV. We know what push. All right, we see push. We see something weird, 0x4005D4 being moved into EDI. All right, I wonder what that is. And we see a call. We see this puts PLT. What is puts PLT? Can anybody answer that?
Puts is a function.
Puts is a function, but I didn't. Why is it there?
Printf.
Printf. That's right. But printf. All right, hold on. Let me get back over to my notes here. Shut up.
Run.
It's the lookup table, right?
Okay, so putsf is putting something into this memory address, and then I see my return right there. 0x1337 is being moved at EAX. I'm seeing that. Then I'm seeing RBP, that return base pointer, right? Thomas, looking right at you.
Yeah, but it's popped this time.
It's popping off the stack. So what we've done is we've pushed it on the stack, we've executed it, and we're popping it back off. Okay? That's all we're doing. So, how does this tell us right here where in memory that string is being printed F? Okay? So what we're going to do is SI, all right? So we've hit our breakpoint, and we want to step into the next instruction. We want to keep stepping SI or step I. Okay, those two things are the same. Again, I just like being lazy. So step or SI or step into. All right. Oh, look, we hit our breakpoint of main. Now we're at the printf function. I'm too sexy for a GUI. Okay, that's exactly where we want to be. But where is the base memory address for I'm too sexy for a GUI? Who can help me get there? What do I need to do? Okay, I'll tell you.
Step one more step.
We're not. Step is a good idea. No. What we're going to do is we're going to use the memory exam tool or examination tool in GDB. Okay, which again, guys, since this is like super introductory talk, I'm just gonna type in. So to initiate that examination tool, we're going to use x/, and I'm going to tell it 24 characters in EDI. We see a move on the third line down. If you see the little arrow over here to the left. Okay, we see this is being moved into EDI. Okay, then this is being moved into this, and so on and so forth. And then we see our return right here. So what we want to do is we want to tell it, I want to display the characters up to 24 in the register EDI. And what we have is I'm to sec KC for a GUI. And that's quick version. So these are the type of challenges that we're going to solve in the Slack channel. Okay, these are the types of things we want to work on together. Because if we jump back to the slide of, well, let me get my thing going here again. So again, guys, everything we just did right here on the slide. Okay, here's the code you can compile. Just copy paste these commands. I've tested it. Blah blah blah. If you have any trouble, somebody in the Slack channel will be able to help. Okay, so
You get to the Slack channel.
we'll cover that real quick. So the demo we just did, obviously. So one of the things when we're disassembling something or we're really just investigating something, this is, and I know what this looks like, but this is what's commonly referred to as a, anybody?
Can't read it.
Stack diagram, okay? This is a notes page, just notes page. All right, it contains all the registers we just talked about, instructions, you know, hex math, etc., etc. So again, we're glossing over that. So real quick, one quick thing I'd like to say is these slides I put under the Creative Commons license. So if you want to borrow them or just take something out of them, you can. All right, guys, that's it. Email me if you have any questions.